All right. This is an old quiz that we used to give in honors pre-calc. And when we do have a quiz over this section, it'll be a similar setup where we have one section where we can simplify all the way down to one trig function. I've also noticed for our AP practice test that we have, one of the free response questions says something similar. It says rewrite in terms of one single trig function. So in this case, it could also be for this worksheet a real number. Like we could get an answer of 1 or 2 or 0 or something like that. All right, so these are not necessarily proofs. You can show as much or as little work as you want. I would begin by changing cotangent beta to cosine beta over sine beta. And instead of dividing by cosecant, which is 1 over sine, instead of dividing by that, we can multiply by sine beta over 1. Sines cancel out. Cosine over 1 is just cosine of beta. For the next one, remember, there's still multiple ways to get to these answers. However, we should have the same, we might have different work, but we should have the same answer for all of these. Okay, so let's jot down the Pythagorean identity that we hopefully have memorized, or if not, you need to start doing that. One of the Pythagorean identities is tangent squared plus 1 equals secant squared. I don't see tangent squared plus 1, but I do have minus tangent squared minus 1. So I could start there. And like I said, there are a lot of ways to go about this work. So if you're looking at it this way, this might be one way to start. So tangent squared plus 1 is secant squared. And so we're subtracting secant squared if we had negative tangent squared minus 1. So secant squared minus secant squared is going to cancel out, and you're going to be left with tangent x. Tangent x. There are also, you could have said secant squared minus tangent squared is equal to 1. Then you would have had 1 plus tangent minus 1, so that would have worked as well. For this one, I could distribute, although I can remember in the first in the first worksheet that we did yesterday and the day before, that there was one problem where tangent plus cotangent was in parentheses, and it was in my best interest to get those in terms of sine and cosine and get a common denominator first. So that's what I'm doing here. I'm using the quotient identities. Change tangent to sine over cosine, change cotangent to cosine over sine. Get a common denominator, which would be cosine theta, sine theta. And this first fraction would get multiplied by sine, so it's going to become sine squared theta. The second fraction would get multiplied by cosine, so it's going to become cosine squared theta. And that's cosine theta times 1, sine squared plus cosine squared, 1 over cosine theta sine theta. And this cosine is allowed to cancel with this one. Now, we're not going to leave it as 1 over sine. We're supposed to leave this as a single trig function. So instead of 1 over sine, let's make that cosecant theta. So the goal here is to get a trig function that's not part of a fraction. So don't leave it in its reciprocal form. Okay, 1 plus cotangent squared, 1 minus cosine squared. Those are not conjugates. They're not going to multiply together nicely. And remember, the general rule is to look for Pythagorean identities first. So let's go back up to this one. If you know tangent squared plus 1 equals secant squared, you should know cotangent squared, theta for this one, plus 1 is equal to cosecant squared. Remember, the trick to remembering that can just be like put cos in front of those. Okay, so 1 plus cotangent squared is the same as cotangent squared plus 1. So this is cosecant squared theta. 1 minus cosine squared. If sine squared plus cosine squared equals 1, this is one of those rearranged versions. It's equal to sine squared. Oops, these should both be thetas. Better switch that for class. And then Cosecant squared times sine squared. Remember, cosecant squared is 1 over sine squared. So those reciprocals cancel out to 1. So this one's numerical. For number 5, I could work on the complex fraction, or I could do Hart method, because I'm noticing, how do I decide between the two? I'm just noticing like, oh, if I divide this out, I would get 1 right here. So that may or may not be helpful. So let's see. Sine x over cosecant x minus cosecant x over cosecant x plus sine squared x cotangent squared x. Well, let's see. Actually, let's change cotangent too. Sine squared x times cosine squared x over sine squared x. So those sine squareds cancel. Sine over cosecant, remember cosecant is 1 over sine. So instead of sine over 1 over sine, you can multiply that. Sine times sine over 1 is sine squared x minus 1 plus just cosine squared x. Sine squared plus cosine squared is equal to 1 minus 1 is equal to 0. All right, last one of these. For this problem, I could change everything to sines and cosines. I think I'll start there just to see what kind of cancels. The other option is like Hart method, but that looks pretty ugly. So, all right, tangent squared is sine squared x over cosine squared x. Cosecant squared is 1 over sine squared x minus 1. So we'll get some things to cancel up there. Before we do that, cosine x over 1, you might want to make it, times tangent squared is sine squared x over cosine squared x, times secant, which is 1 over cosine x. All right, so what cancels? Sine squareds on top cancel. This cosine can cancel with this one. So now let's look at what we have. We have 1 over cosine squared. So we have, 1 over cosine squared x minus 1 over sine squared x over cosine squared x. I was trying to decide, do I want to change this to like secant squared minus 1 over tangent squared? Maybe I do. I could go that route. Secant squared minus 1, check your identity again. Secant squared minus 1 would leave me with tangent squared. So I get 1 in the end. Or I could have down here, I could have said multiply by cosine squared over cosine squared. If you do that, you get 1 minus cosine squared over sine squared. 1 minus cosine squared is sine squared. So you get there slightly differently. Same idea, but slightly different expressions. All right, on to the proofs. So again, when we have a quiz, some of our quiz will be like this, where we're simplifying, not as formally as a proof. You might not show as many steps. Here, the proof, remember, you want to show as many steps as you can, and you have to stick to one side of the equation. So on number 7, it doesn't matter which side of the equation we start on. They're both going to start off sort of in the stuck position here. So I'm going to begin on the left side. And my first step, when I have a fraction with sines and cosines and no identities in sight, is to multiply by a conjugate. So I'm going to multiply by 1 plus cosine x over 1 plus cosine x. That's going to make this sine x times 1 plus cosine x. Remember, the trick is don't actually distribute the non-conjugates together. Do distribute the conjugates. So 1 minus cosine times 1 plus cosine is 1 minus cosine squared x. 1 minus cosine squared x on the bottom is sine squared x. This sine can cancel with one of those. Leaves me with 1 plus cosine x over sine x, which is what the right side of the equation is. So I put a little box to say that it's proven. This next one, definitely start on the left side. It's much more complicated than the right. Okay, You could choose to get a common denominator up here, or I think I'm going to rewrite in terms of sine and cosine here. Actually, no, I'm just going to multiply. I think by now we've worked with reciprocal identities enough that secant times cosine is 1, right? 1 over cosine times cosine. Secant times secant is plus secant squared theta. So we have that. Now be very careful here. This minus sign distributes to both of these terms. So I'm going to do the Hart method. I get minus sine over sine, minus 1, and then minus negative, so plus cosine theta over sine theta, minus cotangent theta or cosine theta over sine theta. We're supposed to show that this gets all the way down to secant squared. So I have a secant squared. I'm supposed to show that everything kind of cancels out. So let's see. So 1 minus 1, cosine over sine minus cosine over sine. So yeah, even though the first step of this was really ugly, all of the work was done in that first step. Okay, on to this one. The left side is more complicated than the right. I see something to the fourth, so that's my hint to factor. So I'm going to begin by factoring this trinomial. And it's backwards, but it doesn't have to be. If you want to make, I mean, this is a positive term. So if you want to put cosine to the fourth as the leading term, you could. But I'm just going to leave it. How do you split up 1? 1 and 1. Oh, 1 and 1. And how do you split up cosine to the fourth? Well, it's got to be cosine squared and cosine squared. Remember, if you get confused by this, you can switch it to like, you can use any letter you want, but we often use u sub. So let's say, let's say that u is equal to cosine squared x. So this would be like 1 minus 2u plus u squared. Like how would you factor that? It'd be 1 minus u, 1 minus u. Or if you spin this around, u minus 1, it doesn't matter. And so then in place of u, I put back the cosine squared. Okay, somehow we're supposed to get sine to the fifth. Well, 1 minus cosine squared should be jumping out at you at this point as sine squared. So each of those are a sine squared. And exponent rules say if we're multiplying common bases with exponents, and we just add their exponents. So 1 plus 2 plus 2 is sine to the fifth. All right, for number 10, I'm going to start on the left side. I see a trig identity down here. This is 1 minus tangent squared theta over secant squared theta. And 1 minus tangent squared is not a Pythagorean identity, but I'm remembering that both tangent squared and secant squared have a cosine squared in the denominator. So that might be helpful to rewrite in terms of sine and cosine. So I changed tangent squared to sine squared over cosine squared. Secant squared is 1 over cosine squared. When we have this complex fraction, we multiply by the denominator that you see. So cosine squared theta over cosine squared theta. This will clear out the complex fraction without having you do math up here, multiply by a reciprocal. This saves you time. It's a lot more efficient to use this method to simplify a complex fraction. Okay, so cosine squared times 1 is cosine squared. The second term becomes minus sine squared. Remember, that's not a Pythagorean identity because it would be cosine squared plus sine squared. Cosine squared times 1 over cosine squared is 1. Look at what you're trying to get. You're trying to get 2 cosine squared. So we need to sub out the sine squared. And we can do that with our rearranged Pythagorean identity. So minus the quantity, 1 minus cosine squared theta. And if you look at that, when you distribute the negative, because you're subtracting the quantity, you get cosine squared plus cosine squared is 2 cosine squared. And then the 1 becomes minus 1. And that's what we were trying to get. Okay, 2 more. Remember, you're not allowed to do this upside down heart. This is bad. You can't split a denominator that has addition in it like that. If the fraction were flipped, we could, because we're dividing each term by a single thing. Instead, I see a bunch of different trig functions, so let's just start by putting things in terms of sine and cosine. So 1 over cosine x times sine x. Tangent is sine over cosine plus cosine over sine. We've added tangent and cotangent together quite a few times. So if you go the common denominator route, like doing the math down here, you should get 1 over cosine sine when you're done. I'm not going to do that. I'm going to clear out this complex fraction by multiplying by cosine x, sine x. So I'm taking a look at the denominators, making sure I have one of each factor represented when I do this. And remember, we're allowed to do this because we're just multiplying by 1. What I have here in blue is multiplying by 1. So you're not changing the value of the fraction. You're just making it convenient for the problem. So sine over cosine times cosine sine. The cosines cancel. The sines are both there, so sine squared x. It's a good sign that we have that. In the bottom, when I distribute this through, I get cosines to cancel, sine squared x, plus sines to cancel, cosine squared x. And that's 1 in the denominator. So that's sine squared x. Okay, last one. I see something cubed. I see something to the fourth. I know that factoring in some way should be involved. So tangent to the third, x minus 1, means I should be using our difference of cubes factoring formula, the SOAP formula. It's going to be tangent x minus 1, and then tangent squared x plus tangent x plus 1 over tangent x minus 1. So the tangent x minus 1's cancel. And then tangent squared x plus tangent x plus 1. Look what you're trying to get. You have the tangent x. You need secant squared. And remember, tangent squared plus 1 is secant squared. All right, so the best way to get used to proofs is just by practicing over and over. If on the first worksheet you used my video for a lot of the problems, or maybe even for every problem, it would be a good idea to print off a blank copy of that worksheet. It's on Schoology, and just work your way through it again before our next quiz. And do a few at a time each day. You're not going to necessarily memorize how these were, although with that said, there really aren't that many unique proofs that we can do. So a lot of the proofs that we have on the quiz, you will have seen at one point, whether it was on this worksheet or worksheet 1 or the next worksheet I'm going to give you. So, not that you should be memorizing all of these, but you'll see a lot of things that are familiar.